Another important strategy that you can use to refactor your monolithic application into a set of services is actually to take modules inside your monolith and turn them into standalone services. So in this segment, we're going to describe this approach in a bit more detail. So the basic idea is to identify a module inside your monolithic application that would be a good candidate to turn into a standalone service. In a little while, I'm going to describe some strategies for identifying and prioritizing the modules that you should extract. The first step in the extraction process is basically to define what you could call an in-process anti-corruption layer. What that means in practice is to identify and define a very well-defined interface between that module and the rest of the system. So it basically makes that interface remotable so that when we turn it into a standalone service, we can introduce some inter-process communication mechanisms, eventing or a REST API, and the rest of the application can use it. But the first step is we're going to do that in place in the context of the monolith, which actually could require quite a few code changes before we're in a position to actually extract it out into a standalone service. So that's the first step. So once we've actually wrapped our module in an interface that's remotable and sort of integrates it in with the rest of the monolith, we can then take that module and turn it into a standalone service. And then we've got our anti-corruption layer, our glue code, that integrates it back in with the rest of the monolith. So you can see by doing this, we've shrunk our monolith by removing that module and turning it into a service. And we can repeat this process. So now we've got two services and our monolith has got smaller. And we can just do this over and over again. And our monolith just keeps shrinking and could actually disappear. Or it gets so small and contains code that never changes, so we don't actually care about it, and it's basically just this part of the system that's there and we never need to touch it. By extracting out code, we're gradually getting rid of the monolith, and any new functionality we're implementing as standalone services. And you do this long enough and you've basically moved to a microservice architecture. So a big issue, of course, a big question that you need to answer is, well, what to extract? So one approach I think is worth thinking about is to actually look at your application and do some brainstorming to come up with an idealized microservice architecture. So sort of have the long-term architectural vision kind of mapped out, where we're going to have these services which have these responsibilities and they're going to communicate in these ways. So that's sort of identifying a goal that we're going to incrementally refactor our way towards. Now that goal should not be set in stone, because this is very much a learning process, and along the way we're going to discover things about our application. The requirements for the application might change over time, so we should be prepared to revise the goal as we learn more. But it sort of kind of sets us off on a path. And then we want to look at the modules in our application and basically rank them by return on investment. What modules that, if we refactored and extracted today, would give us the biggest return for our investment, because this extraction effort is going to take time. And there's a couple of criteria that you could use. So if we have modules that are frequently updated, they might make sense to actually be deployed as standalone services, because then that lets us fully leverage the benefits of the microservice architecture. Or perhaps we have modules that have scalability requirements that are conflicting with the rest of the application. And if we move them into their own standalone services, that perhaps would enable us to scale that service independently and also scale the monolith independently in a much easier fashion. A while ago, probably 9-10 years ago, I worked on this application where we had this monitoring component. We had agents running on servers that published events about machine health into the central server. And to analyze those events, we actually had a complex event processing framework, which let us write sort of SQL-like rules for analyzing these event streams. And it enabled us to build quite a complex or quite a sophisticated monitoring component very easily. But there was this problem. That was a stateful component that we couldn't easily cluster. And because it was embedded inside the rest of the application, it meant that the rest of the application couldn't be clustered. So we could only ever run one instance of that application. And that would be an example of a component that would be great to extract out as its own standalone singleton service, because that would freely enable the rest of the application to be scaled by x-axis scaling. So that I wish we were able to apply this technique for that particular project. One thing to keep in mind is that the process of migrating to a microservice architecture is going to be a learning experience for your team, for your organization. Along the way, you're going to learn about microservices, you're going to learn about the infrastructure that you have in place, the frameworks that you need, and so on. And so when you start migrating your application to microservices, the first few services that you're going to define should sort of be simple. They shouldn't be particularly mission critical, just so that you can practice writing these microservices, practice extracting them out of your monolithic application, and then once you've got the hang of that, you can start working on much more critical modules, and then fully sort of start going down the path to a microservice architecture. Another thing to consider is you want to look for natural seams within your application, because these seams represent easy sort of boundaries between components that you can then split apart and put into separate services. So, for instance, many applications have an architecture that looks like this, where they're monolithic, but they have components that only ever interact through a messaging system. So that basically represents a very natural seam, because these components don't communicate directly. You don't have transactions that are spanning multiple components, and so it's very straightforward to split those components out into their own separate microservices. So that's the big idea. So you can incrementally extract modules. The order in which you do it tends to be in terms of which modules give you the greatest return on investment. Though initially you want to pick modules that are kind of simple so that you can practice and gain experience with doing that. And you also want to try and identify natural seams within your application, because that can provide very easy ways, low-hanging fruit, as you could call it, for easily extracting modules out of your system.